Hi, this recording is going to go over Unit 4 in the Math Plus Red, and this unit has been completed by a lot of you, but I did want to go ahead and focus on this extended problem solving activity that reiterates a lot of things that were taught in this unit, and it also goes into some real world problem solving that can be a little tricky at times. So let's open up the document camera and let's take a look at this activity. In the real world problem solving lessons, most of them integrate things and concepts that are not just in that unit. And this is exactly what happens in Unit 4, because not only are we reiterating the angle size and different types of lines, as you go through, there are activities that focus on area and perimeter. There's also some activities that focus on unit conversion. And then students may just not have had a lot of experience in measuring angles. So we're going to work on that and go over this lesson so that we can talk about the importance of not only just getting answers, but helping students realize that math is used in the real world. A lot of times students think of math as, oh, it is my subject that I just need to take in class just to get a grade and just to get an answer. But math is something that we use every day, and we want students to persevere and use problem solving. Things aren't always easy, just like they're going to see when they get into the real world and get a job, that sometimes coming up with the solution takes a little effort, and they may make a mistake, but we learn from those mistakes. And that's exactly what these open-ended problems will help teach your child. With this activity, the first lesson talks about copying the sign and making this little train. What I recommend doing is getting graph paper, or you can also print out centimeter grid paper from the internet. I'm using graph paper just because the squares are smaller and it's easier for me to show. You also can access centimeter grid paper in the lesson section, the resource section of the Learning Coach Guide. Now also, while I'm thinking about it, along with the problems, you also have access to this answer key that helps work it out and give some potential feedback. So as we go through this, I'm not going to answer all the questions fully, but I am going to give you a few tips and tricks to help your child be successful. If you use grid paper for something like this, you can encourage your student to already implement the right angles that are on the grid paper. So right here we have 11 across. So I'm going to go 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to go 6 up. 1, 2, 3, 4, 5, 6, 4 over, and then 2 down. And you can see I've already made all of those right angles very, very easily. When I go 4 across this way, I then have this particular line. I'm going to double check that I have 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And what students can do is kind of connect and just see if their angles really are 120 and 60. It isn't, the goal of this lesson shouldn't be just that they're exactly perfect, but that we are learning how to use a protractor and learning how to line that up, learning to use the 0 to start measuring, learning to use this center dot to focus on that vertex of that angle. We don't want to use this bottom line. We always want to use this line right here. And so just encouraging students to use their protractor. You can see that I know it's hard to line it up exactly perfect, and even for me, my little line doesn't come out exactly at 60 degrees. That is okay. So do not stress about that. Just encourage your child to work on trying to replicate this the best they can, and especially learning how to draw angles. I think one of the funnest things to do is to just draw angles however you would like. So if we want to draw, I'm going to start here with a straight line so I can line it up perfectly. And I'm going to have this as my vertex so I can see it easily. If I have that lined up and I want to draw an angle that is 120 degrees, I can put my little dot here. And this, I like this protractor because it has that extra arm. And so we can then connect the dots and have our 120-degree angle. So I think just learning how to use a protractor and then reiterating the vocabulary, such as on this drawing, we have perpendicular lines, we have parallel lines. Right here, this line and this line are perpendicular because they have a right angle in the corner. This line and this line are parallel. Again, talk about obtuse, acute, and right angles. You can also talk about what happens when you decompose a shape. Shapes are often made up of other shapes. So in this right here, we have four sides. This is a quadrilateral. This is also a quadrilateral with four sides. And they also have a special name called trapezoid because we have two sides that are intersecting and two sides that are parallel. Just like this one, two sides are parallel, and these two sides, if they went on and on, would intersect. So have fun with this. Use your protractor. Measure things around the house. That's the most important thing. Here we have a problem that involves area, and a little girl has the offer or ability to do two different paint jobs. So one paint job has a fence that's 38 by 4, and this is our 38 by 4, and then another paint job is 27 by 3. So we have 27 feet by 3 feet. The thing that I like about this activity is it reiterates things that were taught in a previous unit, like multiplication and division, but it also focuses on how this number 38, the 3 is not just a 3, it is a 30. And so we have a 10, a 10, a 10, 10, 20, 30, 8. We can use the area model to figure out how many squares there are in all by doing one section at a time. Because if this section has 10, I know 10 times 4 is 40, 10 times 4 is 40, 10 times 4 is 40, and this section has 8 times 4, which would be 32. If I add all of those up together, I end up with 152. I would get the same answer if I multiplied using the standard algorithm, but the thing that's important for fourth graders to understand is the value of the digits and how that relates to multiplication. Here's the same type of thing. We have 10, 20, plus 7 more. So if this was a 10, I'd have 30 and 30, and 7 times 3 is 21. The thing with Mr. Lopez's fence, though, is he wants both sides of the fence painted. So everything we do is going to have to be multiplied by 2. So if we added this up, we would have 60, 70, 81, but I need it 2 times. So his fence is going to be 162. So they're very close, but now we know which one is larger. Now this question down at the bottom talks about division. And it says Miss Jolly wants to pay Addison $1 for every 4 square feet of fence she paints, and Mr. Lopez wants to pay $1 for every 3 feet. The thing that's really cool about this, you may be tempted just to set up the standard algorithm and divide like that, but our drawings can help us. If he pays $1 for every 4 feet, well, here's $1, there's $1, $2, $3, $4. You can continue to go through and add it up like that. We want students to realize that it's all about equal groups when we divide. This, you could do the same thing, but do it twice because he paints the front and the back. If we did follow the standard division algorithm, which is not supposed to be really taught until 6th grade, I would rather you use the partial quotient and really have students think about how they're dividing this up. So we have 3 into 162, but we could start off with, well, I know that 3 times 50, let's do that. 3 times 50 is 150, just using my knowledge of tens, because I know 3 times 5 is 15 and I make it 10 times bigger. And then I could subtract to get 12, and then I know 3 times 4 is 12. When I add this up, I can see 3 went evenly into 62 54 times. So this one, she would actually make $4. Now let's move on to the next activity. And this one is a little tricky because it starts dealing with perimeter and missing sides. This is where I think it is great to get out that centimeter or graph paper again and really help students think about, okay, if we know, and it's a multi-step problem, but it says the area of the garden is 128. And I'm not going to use these specific squares exactly. I just want to show you. What we want students to realize is that if we know the width is 8 feet, that means it's 8 feet on this side, we don't know these two sides. So we have to think, what times 8? 8 times, we could use it, let's do the length since the length is missing. 8 times the length equals 128. We don't know that. So we can use the inverse operation and we can say 128 divided by 8 equals that missing, because multiplication and division are opposite operations, and this is kind of like a fact family that your student probably started learning back in kindergarten. So again, we can take that situation and divide 128 by 8 by using things that we know. I know that 8 times 10 is 80, so I can take away a group of 10. And when we do that, 8 minus 0 is 8. 12, take away 8 is 4. I know 8 times 6 is 48. And then I have nothing left over. So when I add these two together, I have 16. So it goes 16 times. So now I know my missing sides. And to get the perimeter, we add up all of those missing sides.